Hello and good afternoon, ladies and gentlemen. Welcome to another video tutorial to walk you through how to solve some of these questions here on your Lesson 10 problem set. So, question numbers 1, 3, and 4 were given to you as your assignment on your Google Classroom. That needs to be turned in tomorrow by 2:30. So 1, 3, and 4, not ones I'm going to go over. I am going to go over, though, on page 103, question numbers 2 and 5. Simply so that way we can understand and see kind of the other examples here and try and make sense of what our goal is in solving these questions and answering these questions. So I want to take a look specifically at question number 2. So we're going to start there. Alright, I'm going to use both this little bit of area here as well as I'm going to be jumping over to my other page, this blank page, and to be able to do all of my work there. And I will show that. I'll slide it over. Zoom out just a little bit so that way it'll make it easier to make that transition. And then we'll just take it one step at a time, A, B, C, and D, just like your assignment is. So, question number 2. Erica drives from school to soccer practice 1.3 miles away, and it takes her 7 minutes. So for part A, they want to know what fraction represents her constant speed. Again, we assume that she moves at a constant speed, she drives at a constant speed, and so we have to take our pieces of information, put them together in a fraction to represent that constant speed. Speed, as always, is distance divided by time. So over here, with question number 2. Oh, can't see that. Slide that down a little bit. Question number 2, part A. I need to create a fraction to represent her constant speed. Alright, I'm going to use C to represent my constant speed, as the question asks me to. So C is equal to distance, which is 1.3 miles, divided by time, which is 7 minutes. Okay? So 1.3 divided by 7. Easy. For part B, it asks, what fraction represents her constant speed, C, if it takes her X minutes to go 1 mile? Okay, so they again want you to create another fraction here, but in this case they give you a mileage factor, they give you a distance to plug in, and then they want you to find the time. Alright, so in terms of X and Y, we've talked about before how your constant proportionality, constant speed, your slope, whatever it is Y divided by X, your distance divided by your time. In this case, they give you a distance, and they don't give you a time. You have to solve for that time. So our fraction is going to look like this: 1 mile over X minutes. We don't know. We don't know how many minutes it's going to take to go exactly 1 mile. So for part C, what they want you to do is to set these two fractions equal to each other, to create equivalent fractions. So, to have 1 over X be equal to 1.3 divided by 7. So that's what we're going to do here. Much like we did at the end of lesson 8, we're going to now cross multiply. We have equivalent fractions. We need to know what that denominator is on the left. So we're going to cross multiply to find our answer. X times 1.3 is 1.3x. That's equal to 7 times 1, which is 7. From here, we have a one-step equation. We divide both sides by 1.3. And it does tell us to round our answer to the 10th place. Because it tells us to round our answer, you're going to want to have a calculator. Okay? So, got a calculator. We're going to plug in 7 divided by 1.3. Oop, not 1 negative 3. Wrong button. 1.3. And that's going to give us 5.38461 blah, 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 blah. Okay? Repeating decimal. So what we're going to need to do is just round that to the nearest 10th place, it says. My nearest 10th place is right now a 3, so I'm going to round that up because of the following number making an 8, and I'm going to make that into X equals, or rather is about 5.4. So, to answer our question, it takes Erica about 5.4 minutes to go 1 mile. About. Okay, so we have the little squiggly line there, not an exact equal sign. It's not 100% equal. It's close. Okay, we rounded it. And then for part D, okay, they ask you to create an equation, much like we've done with other equations, a two-variable equation to represent how many miles Erica can drive over any time interval. Okay, over any time interval. As we've said before, when we have this c, this constant speed, that is our constant of proportionality. So we're going to use both values that are given to us, and we're going to always take the top value as our y and the bottom value as our x. Okay? So when we do that, we put those together, and that gives us our constant proportionality. That gives us our k. That gives us our m value in our equation. So we're going to take y being equal to 1.3 divided by 7 times x. This is going to be our equation. So now any time interval that we want to know, we can plug in for x, and it'll give us a particular mileage. And you might think to yourself, Mr. Streams, how do we get that? Okay, I'll show you here in a second. Show you how we get this. We take this up here, and we essentially set it equal to y over x. We then cross multiply to get 7y equals 1.3x. And I think you can see where this is going. Divide both sides by 7. And you're left with y is equal to 1.3x divided by 7. Or 1.3 divided by 7x. Either way, these two things are the exact same thing. This is our equation for part D over any time interval. We can plug in an x, or we can plug in a y value to determine how many minutes it takes her to go a certain distance. Okay? Now, let's take a look at question number 5. Question number 5, you're also going to want to have a calculator ready, so don't put it away yet. Question number 5. Uh-oh. Knock down on my popsicle sticks. Cool. Question number 5. Let's take a look at it before we begin to solve. Carlos walks 4 miles every night for exercise. It takes him exactly 63 minutes to finish his walk. So assuming he walks at a constant rate, we need to create an equation that is going to represent how many miles he walks in x minutes. Y miles in x minutes. Okay, again, we're looking for speed, distance divided by time. So when we create the fraction, like we did in part A, we take the distance divided by time. In this case, 4 divided by 63. 4 miles in 63 minutes. Now, what they want is the equation. So we have to take this constant speed and plug it into our equation for our k, for our m, for your constant proportionality, your constant speed, whatever you want to call it. It's all the same value. It's your y divided by your x. So here, just like we did in question number 2, we took it and we plugged it in as our coefficient for x. We're going to do the same exact thing for number 5. We're going to take our fraction, 4 over 63, and plug it in as our coefficient of x into our equation. So we're going to take the equation, which is y equals, and then we're going to have 4 over 63 times x. This is our equation. Then for part B, we need to use that equation to then fill in the rest of these for figuring out how far we can go in X amount of minutes. So we have 15, 30, 40, 60, and 75 minutes. We're going to take each one of those numbers, plug them into our equation for X, and figure out what Y is. Okay? So, like this. Y is equal to, luckily for us, Y is all by itself, so whatever we get when we do our multiplication, that's what our answer is going to be for how many miles. So it's going to be 4 over 63 times 15. Okay? The reason we're multiplying it times 15 is because that's our x value. It's our given x value here for this point of data. So we have 4 over 63 times 15. So when we multiply fractions, we have to multiply straight across. So that gives us 4 times 15, which is 60. Okay. So then 60 divided by 63 is 0.9523. So we're going to round that to our nearest tenth. nearest hundredth place. So it's going to be 0.95 miles. We're going to do the exact same thing with 30 minutes, 40 minutes, 60 minutes, 75 minutes. So y equals 4/63 times 30. Y equals 4/63 times 40. Y equals 4/63 times 60. And finally, y equals 4/63 times 75. So let's do some math here. 4 times 30 equals 120 divided by 63 gives us about 1.90. Okay, about 1.90. That should make sense. We went from 15 to 30, that doubled, and so our y value should also double. Again, these are all roundabout numbers, but in this case, it does double. So, for the next one, 4 times 40. Put that on screen there. 4 times 40 equals 160 divided by 63 is 2.53968, blah, 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 blah. So we're going to call that 2.54. We're going to round that 3 up to a 4 because of that 9. Then for 60, okay, so we have 4 times 60 equals 240 divided by 63. And that's going to give us 3.809. So we're going to round that up to a 1. And then finally the last one is 4 times 75 is 300 divided by 63 is 4.76. There's only a 1 following 6, so we're just going to leave it as 4.76. That is how we, number 1, use an equation to fill out a table. And number 2, now we have data points, where from here, with these data points, we're going to graph into the next lesson.